All right, let's go to the actual examples now. Check it out. Using these rules, let's go ahead and do this. I'm going to power through this pretty quickly because I don't think this is that difficult. The rules that we're going to be using here, x to the third times x to the sixth, we just add those exponents, x to the 9. X to the 7 times x to the 8, pretty simple. Just add those exponents and you get yourself x to the 15. X to the 10 over x to the 2, we're going to subtract those. 10 minus 2 is a positive 8, which means it's going to go on the top. So you'll end up with x to the 8 over 1, but do we really write that 1? No, we don't. We write it like this. So 9 minus 8 is a positive 1, which means it's going to go into the top. So we have x to the 1 over 1. We don't write it like that. It's going to look like this. Now let's check it out. This is kind of fun. We have 2x to the 7th times 3x to the 8th. Your rules for multiplication are still the same. So 2 times 3 is 6. All right, we have this x here. And what do we do with our exponents when it's multiplication? You add them. That's the rule for that. All right, this is now saying division. X to the 15 divided by x to the 8. What do I do with that? 15 minus 8 is 7. And what's on the bottom at that point? Just a 1, but it's silly to write it like that. It's a very loud cart. Hold on. Okay, so that's that. I don't know if you can hear the cart in the background. Someone brought a very noisy cart down. Okay, so this is pretty neat. Why does x to the 0 equal 1? Pretty cool. It's in the notes. I actually didn't see this in the notes. I should have seen this. I don't know how I missed it. It's pretty neat. Why is this the case? Well, check it out. This is pretty self-explanatory here. Why it equals to this? Because what ends up happening if I had x to the 7 divided by x to the 7 and I did 7 minus 7? I'd have x to the 0. But look at this. Anything divided by itself ends up being 1. So x to the 7 divided by x to the 7 is actually 1. But it actually is the same thing as x to the 0. So they kind of derive the rules from this. It's kind of neat. It's a math trick. There's actually more videos online that do go into more in depth about this and some cool implications, but that's only for those nerds who are interested in it, people like me. All right, so now let's talk about how to solve that. This is how we do it. X to the third is going to stay the same, obviously, but y to the 0 will turn into 1. So what is x to the third times 1? Y'all, it's just x to the third. 2 to the 0 turns into a 1, so 1 times x to the 5th is just x to the 5th. And remember, it doesn't turn into 0. It does not turn into 0. If it turned into 0, it would erase everything. It turns into 1. Check out this. They're saying this entire parenthesis is raised to 0. So that means this entire thing evaluates to 1. So pay attention to those little tricks on there. It's not that big of a deal. Now I'm going to go ahead and solve these problems. This is x to the 5th raised to the power of 3. So the rule for that is you multiply those. So we have x to the 15. Now I have x to the squared raised to the power of 3. You multiply those and you have x to the 6th. X to the 7th raised to the power of 4th. You multiply those, you get x to the 28th. X to the 6th raised to the power of 2. You multiply those and you now have x to the 12th. Now, this actually has some numbers in it. Y'all, the rules do not change just because we're adding another rule to y'all. What is 2 to the 4th power? 2 to the 4th power, 2 times 2 times 2 times 2. That is going to be 16. 16. What's our rule for exponents? 2 raised to the 4th power is going to be 8. So that comes out to 16x to the 8th. Now, I'm going to square this 3, which is going to give me 9. I have an x I have to worry about. 3 raised to the power of 2 is 6. So that's the basics on that. That's the main page of that notes right there. I'm going to go to this page on the next video.